All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 2.2 in Algebra 2, which is properties of exponentials, and we're going to talk about simplifying exponential expressions in this video. This is the second video in the series. So let's start off with something from page 95 of your textbooks, which is property of exponents. So they all have names. I'm not particularly concerned whether you memorize the names or not. It doesn't bother me either way. But let's walk through what these properties of exponents look like and what they do real quick. And then we're going to talk about applying them for the rest of this video and pretty much all the other videos in this section. So the first one is that if you have, so if we have an exponential expression, right, with base A or B, right, A and B are non-zero real numbers. If you have two of the same base to different powers, then when you want to combine them, you sum the powers. So for instance, if I had A squared A cubed, it would become A to the 2 plus 3, which would be an A to the 5th, right? If I have an A to the m on top of an A to the n, I combine the exponents by subtracting. So for instance, x to the 5th over x to the 2nd would be x to the 5 minus 2 or x to the 3rd, right? And there's another way to think about that, and we'll talk about that in a minute. If I have a power on a power, right, if I have a y to the 5th to the 8th, it's going to become a y to the 5 times 8, which would be y to the 40th, right? That's a 5 times 8. Oh, okay. If I have a power on a set of parentheses, like let's say I have a b to the 3rd, I can take this power and multiply it by the powers already on the a and the b and make this a to the 3rd, b to the 3rd, right? And the same thing's true if I have a quotient, right? If I have some x, let's do x squared over y, and we'll do it to the 3rd. I can take that 3rd and distribute the power, and the top would become x to the 2 times 3, which would be x to the 6th. The bottom would become y to the 1 times 3, which is y to the 3rd. Okay, so those are our properties. One way to talk about this quotient rule, right? So if we look at this quotient, just as a side note, right? This subtraction is definitely the way it completely and totally actually works, right? But sometimes when we do this, we want to think a little bit more about logic, right? So if I have something like x to the 3rd over y, not y, my bad, come on brain, over x to the, let's say, 10th, right? This is going to be an x to the 3 minus 7, which is fine, but that's going to be, sorry, 3 minus 10, come on brain, did it already, which gives me an x to the negative 7th. Now that's fine, but that's not my final answer because we generally want the final answer to have no negative exponents, which we'll talk about on the next slide. So I'm going to write that as a 1 over x to the 7th, right? So those are our properties of exponents. So another couple quick properties of exponents, and I believe I mentioned them in the last video, but it's been a while since I recorded this video because or the 2.2 section 1 video, because unfortunately the second video in this section got lost and I am remaking it now. So if you have something like an a to the negative n, that's the same as a 1 over an a to the n. A negative exponent essentially means, hey, I'm on the wrong floor. So similarly, if you had a 1 over a b to the negative n, you could flip that guy up to the top floor and it would be a b to the regular n. All right, so moving forward, let's go ahead and talk about what it means to fully simplify. So if you fully simplify an exponential expression, then what you're doing is you're making sure that it only has one of each base, that all the coefficients are at the front and in the lowest terms, and that there are no negative exponents. So let me illustrate number 1, right? So if I had a squared b squared over a to the 7th, the reason that that one's not fully simplified is because there are two a's, right? So that's a violation of this only having one of the a's. So what's going to happen is that's going to end up being a b squared over an a to the 5th. The way I got that, by the way, if I do top minus bottom, I get an a to the negative 5th, and I recognize that actually lands on the bottom, right? So again, if I do top minus bottom, the top exponent, the 2 minus the 7, I get an a to the negative 5th, and I know that really lands on the bottom, right? The other way to do that is to think about this as a tug of war, and the a to the 7th definitely wins, right? Now let's say, let's go ahead and look at an illustration of number 2, right? So all coefficients are at the front in the lowest terms. Let's say I have 2a squared 3b to the 4th over, I don't know, let's say a 12, right? So that would be a 6 at the front, a squared b to the 4th all over a 12. Now my coefficients are all at the front, but they're not in lowest terms because the 6 and 12 would cancel, so I'm going to end up with an a squared b to the 4th over 2, right? That's what I mean by at the front in lowest terms. And then the last thing, if we talk about the idea of no negative exponents, well, let's say I had something like an a to the negative third, b to the fifth. I don't want to leave it like that. I want to rewrite it as b to the fifth on top of an a to the third, because that would land on the bottom. Okay, so that's what we're talking about. So let's go ahead and do an e2 and a p2. So for e2, notice there's no extra powers on anything, right? So I've got a 3, and it's basically, it's multiplied by an x squared, a y to the negative second, a negative 2, right? An x to the third, and a y to the negative fourth. So you don't have to do this, but my suggestion is, since this is all multiplication, put stuff in the order you want it. Put the coefficients at the front, so that's a negative 6, right? Put the x's next, so that's going to be an x to the second times an x to the third. Well, that's going to be an x to the 2 plus 3, which is 5, right? And then you're going to have a y to the negative second and a y to the negative fourth. Well, that'll be a y to the negative 6. We're almost there. The only thing is we're not supposed to have any negative exponents, so I'm going to flip this guy back to the other floor. Remember, a negative exponent means, hey, I'm on the wrong floor. So a negative exponent on top means move this thing to the bottom. A negative exponent on the bottom would mean move it to the top. All right, last one, we'll do a P2. All right, so same idea. You can pause me if you want to do this without me. Remember that this is all multiplication, right? So there's no powers on any of this. This is all just a big blob of multiplication. The parentheses are mostly just there to confuse you. They just mean multiplication here. So the first thing I'm going to do is put all the coefficients at the front. Seems to me that my coefficients are 2 times 3 times 5, which should be a 30, right? I'm going to deal with the x's next. There's only the one set of x's. That's an x squared. That's it. And then I'm going to go ahead and deal with the z's. There's a z and a z to the negative third, which should remember that no power is a 1, so that's a z to the negative second. I'm almost there, but this guy needs to go on the bottom. So my final answer is going to be a 30x squared over z squared. And that's it. So that's our second video. Hopefully it does connect the dots between the first and the third video. Again, the second video was inexplicably lost like the city of Atlantis, and so I had to make a video on the fly to fill this spot. I apologize.